three equations, three unknowns. Really, we're going to be working with three planes and trying to figure out how they intersect. Now, in this video, I'm not going to give you an intuition, or at least a full-out intuition, in terms of how three planes can intersect. I did that already, actually. I took a little bit of time to try to show you, the learners, the students, to try to tell you, what happens with three planes. And I did a video which basically shows how planes are intersecting. So maybe they don't intersect at all because they're parallel. Maybe they're intersecting, okay, in terms of a line. Maybe they're on top of each other, so they're intersecting at the entire plane. So there are many different ways that three planes can intersect. And I did a video on explaining all of this with regards to three planes, and I'll put up a link up above there. In this video, my interest is going to be by examples. So if someone actually gives you three planes, which we typically will write in kind of this system of linear equations for ourselves. So you're going to have three, you're going to be lining up your x's, your y's, and your z's, okay? And then typically the d will get shifted over on the right-hand side, as you see here. Once you have this, you can, and you definitely do have the tools to be able to figure out what happens to these planes. So either intersecting, either not intersecting, and if they are intersecting, how? So let's take a look and dive into these three examples to try to illustrate to you what the steps actually are. So I'll take the first example. So here it is. This is three planes, and what you will try to do in order to be able to see, if they're going to be intersecting or not, you're going to begin just with two planes first. So for instance, it doesn't matter which ones you take, and I'm going to take, these two particular planes, and I'm going to try to see what happens to them. And I'm going to use the process of elimination here. Now, elimination meaning I'm going to eliminate one of the variables, right? So I want to be able to see what happens. Now, you can very quickly just scan and then see if there are actually any normals of the actual planes, to be able to see if the planes, okay, or any of the planes are actually parallel to each other. Now, how does that work? Well, you would take your normal and then you would try to see if there is a multiple of another normal. So basically the normals are scalar multiples of each other. And if they are, okay, then you're going to know that the planes are parallel. Then you can check if they're actually the same plane, so they're on top of each other or not. So for us, I'm just going to use the process of elimination. So I'm going to take the two that I just listed here, and I'm going to kind of see what happens and eliminate. You can eliminate either the x, the y, or the z. And the process of elimination is exactly what you've learned in grade 9 or 10. So I'm going to actually multiply this one by 3 because I want to get rid of the x, all right? So I'm going to take my first one, 3x minus y plus 5z is equal to 2. And here I'm going to get 3x minus 3y plus 3z is equal to 0. So I just multiplied it by 3, and I want to get rid of this, right? So I can subtract the two planes from each other, and let's see what I'm going to get. So within here, so what I'll get is, so it's going to be negative, and then I guess this is plus 3, so this is going to be 2y, and then, subtract, so 5 minus the 3, so it's going to be plus 2z, and then this is going to be actually 2. All right, so if I did that correctly, so let's just double check. So negative 1, that I have in there negative, then it's a plus 3. So yes, so that's correct. Okay, and then 5 minus the 3, and then 2. Okay, so this is what I have. So if I have this, now what does this tell me? From the knowledge of intersection of two planes, this basically tells me that these two planes are intersecting at some line. That's what is going to happen. So really, what I have is I'm going to have one plane, and then I have another plane. So this particular plane, I don't know how exactly they look like. It doesn't really matter. It's not what we're being asked here. But they're going to be intersecting over here. There's going to be a line of intersection right there. Now I can find that line, but that's not what I'm looking for. I'm looking for where the three planes are intersecting. So I know that these two are going to be intersecting at some particular line. Now, what do you do next? Well, you can't really do much with this one. You don't have to find the actual equation of this line. You just kind of leave it. And now next, what you're going to do is you're going to take two other planes. So you're going to take planes, okay? Again, it doesn't matter which two, just not the same two planes. So for instance, I can take these two planes right there. Okay, so the first one and the last one, and then I can see. So since I eliminated the x, once you eliminate and you choose a variable like x, then you stick with that. So that means just eliminate x entirely. So now from the other two equations that you chose. Now, in order to do that, I'm going to have to actually multiply. So I'm going to have to multiply this one by 2. So this is going to give me 6x minus 2y plus 10z is equal to 4. And then my other one, which is 6x minus 2y plus 10z is equal to negative 4. Well, look what I noticed. I actually noticed that the x coefficient, the y coefficient, and the z coefficient are identical. So I don't really have to go any further than this. I know that this is going to give me, I don't have to go further. I know that this means that the two planes are parallel because their normals are scalar multiples of each other, right? And the multiple is actually 2, okay, because that's what I did. So I know that that's going to happen. Now let's just double check and see, okay, if they're the same plane. Well, they're not going to be the same plane because of the fact that I have a 4 and a negative 4. Now, if these two were equal to each other, that means these two were the same plane. Now, this is going to fall off for you if you actually do the algebra in here. So you actually just do the arithmetic. So this is going to be 0, 0 and 0. So it's going to be 0 is equal to, and then notice this is 8. And what this tells me, these are obviously not equal to each other. So what that means is that these two planes, so if I would take the two planes, if this was my first plane, right, and then this was my other plane, so that means that they actually do not intersect. And what this tells you is you stop right here. You don't have to go any further. You know that if two planes are not intersecting, then clearly three planes are not going to intersect. So really you have the case that you have, another plane. Okay, so let's say if this was extended here, I'm going to just extend this just so that you can see it visually, this is kind of what it looks like. Again, I'm just sketching these planes. I don't know exactly how they look like, but what I do know is that, so there's another plane, okay, in this way, and then these two, so maybe, let's call this one was the first one, this is the third one, this is the second one. So that's what actually we are observing. So we know that these two are going to be parallel to each other. And because there is no solution here, we do not have to proceed any further. So this is no solution. Now, I doubt that your teachers are going to be asking you, like exactly what's the intuition behind this. Yeah, like what are you doing? They're just probably asking you, solve the system of linear equations, these 3x3s, and tell me what the answer is. So here you would say, well, there is no answer, and we can see that right there because when we try to eliminate our x, we've actually eliminated all the variables, and then we got 0, which is supposedly equal to 8, which is never true. So that just tells us that there's no solution. All right. So that's what we would do with this one. Let's try, our second example. So I'll try this example and see what this gives me. So copy. This one has decimals, so I don't really like it, but that's fine. So we're going to try to get rid of the decimals. So remember when you used to do these, if you do have decimals, you can get rid of the decimals if you wanted to, right? So you can multiply by, for example, here, the first equation, you can multiply that by 10, and that's going to get rid of the decimals because there's one decimal value. Actually, we can multiply this by 2. So let me do that because I don't like these decimals. I'm going to multiply this by 2. so that I get 4x minus y plus 3z is equal to 8. I guess that's what I have. I think that's true there. So this is what I have for the first one. At least this way I won't have to worry about that. My second one, notice this one, is 3x minus 3y plus 3z equals to 6. Actually, this one I can rewrite. So notice I can divide this one, divided by 3. And so the only reason why I'm doing that is because I don't want to be dealing with bigger numbers to get rid of. So this is what I should get. Okay, so that's going to be this one. And then the last one, again, I can multiply this one by 2. I'm just getting rid of the decimals, that's all. So it's going to be 2x plus 3y minus z is equal to 5. Okay, well, that's much nicer to deal with because now they're just all integers. Now, if you can't do that, right, if you do have decimals, I'm sorry, tough. You're going to have to deal with them. But I assume that, you know, in school when you're dealing with these and you're doing quizzes or tests or something, they're not going to give you enormously huge coefficients or just very strange coefficients in terms of decimals. They're going to give you something manageable. Now, if you want to go back and think, you know, how do you get rid of decimals, I'll put up a link up above there to the grade 10 video, okay, in terms of coefficients, except back then you were only dealing with 2 variables, x and y, but it translates to this as well. So you can look at that one. So now let's take a look and see what we're dealing with here. You know, so how does this exactly, you know, look like? I can just do a little bit of a scan. I don't really see that the planes are parallel to each other because I'm looking at the normals. So it's easy to check, right? If they're scalar multiples of each other, you can just divide. So notice the first and the second, it's not going to work. Yeah, it doesn't look like it's going to work. All right, so let's get started and let's see what happens with these. So I'm going to take these two. Again, it's your choice what you're going to get rid of, right? You know, I typically start with the x, right? To just try to get rid of the x and it works fine. You can do the y, so you can just get rid of the y's, or you can get rid of the z. I actually will get rid of the y because of the fact that I don't actually have to multiply these two at all because they have the same coefficient. So I can just add those together, right? So if I add those two together right there, I'm going to get, so this is going to be subtract, because they have the same one. So I'm going to be subtracting. So 4 minus the 1, so that's going to be 3x. My y is gone, and then 3 minus the 1, so that's going to be 2. Z is equal to 6. Okay, so these two planes, basically what this tells me, since this is, I don't have a 0 on the left-hand side, so this indeed will intersect at some line. All right, so those are the first two. Now let's, you know, pick another two. Now again, it doesn't matter which ones you choose, just don't choose the same two. So I'm going to just work with these two this time around. And since I'm getting rid of y, I'm going to continue to get rid of y. So once you make that choice, just get rid of y. So you're only stuck with 2 variables after, in this case x and the z or the z. Okay, so I'm going to work with these two. And in order to do that, let me just erase this. So I'm going to take this, I'll multiply this by, sorry, not by 2, by 3. And that is only because I want to get rid of that y. So this is going to give me now 3x minus 3y plus 3z is equal to 6. That's that first. And then, so here I don't have to change anything. So 3y minus z is equal to 5. Okay, so now I'm not going to subtract them. I actually do have to add them now so that I get rid of the y. So this is going to be 5x, and this is going to be added together. And that's going to give me, so 3, so minus, so that's plus 2, Z, and then this is 11. So what that tells me is that these two lines are also intersecting, these two planes are also intersecting in a line. So I have an intersection, so from here, so I know that I'll have, one line, this is from the first two, and now I have, okay, the other one also in a line. Now, I don't know, right, how these lines exactly are. So I want to just make sure, okay, do these lines actually intersect? Okay, and then how are they going to intersect? Are they going to intersect at a point, right? Are they going to be parallel to each other, or not intersect at all? Or maybe they're skew lines. Now, because we're working with planes, they won't be skew. But in this case, we can just double check, okay, what happens. Now, looking at the coefficients, they look actually pretty good. Notice this one's 3, this one's 5, this one's 2, and this one's 2. It doesn't look like they're multiples of each other. So it looks like this might be intersecting, okay, in some particular way. So let's just take a look and see, okay, so what happens here. So I'm going to now take these. So the next step is you're going to take now these two. So I'm going to take this one and this one. So this is going to be now 3x plus 2z is equal to 6, and 5x plus 2z is equal to 11. So that's what we're going to have here. And so now, okay, so with this, now you're going to go back. Now this is just, two equations, two unknowns. So now let's eliminate one of them. I'm going to eliminate the z or the z because of the fact that they have the same coefficient. It's much easier for me to do that just by doing subtraction. Now, if the coefficients were not the same, then you would have to multiply one of them or both of them to try to get rid of, okay, one of the variables. So this is going to give me negative 2x, okay, so this is gone, and 6 minus 11, I guess that's negative 5. So x is equal to 5 over 2. So that's pretty neat. So what does this tell me? This tells me that the two lines that I have found actually intersect at a point, right? So these two were intersecting at some point, and now I found the x value for this. The x value for that point is 5 over 2. And now what I have to do, now that I have x, I can now go back, so from here, and substitute into one of these equations. So either I can substitute into this one, or I can substitute into this one. And what I'm going to do is, what I'm going to get is, now I'm going to be able to solve for my z value, for my z value. Okay, so let's do that. Okay, within here, sorry, I'll keep this as blue. So I'm going to substitute into this one right there. It doesn't matter. So I'm going to get 5, notice 5 over 2 plus 2z is equal to 11. So this is going to give me 25 over 2 plus 2z equals 11. So bring this over on the other side. Now I know this is annoying because it's a fraction. That's fine. Okay, so what do I get? You can pop this out in your calculator. Okay, use your fraction buttons, or you can do it in your head if you like. I just want to be a little bit quicker. Okay, so let's see what this gives me. Oh, so this actually is a pretty nice one anyways. So that's just negative 3 over 2. So that's that. Divide both sides by 2, and I'm going to get that z is equal to negative, sorry, this is negative 3 over 2. So this is going to be negative 3 over 4. All right. So that tells me, okay, again, that this intersecting point between those two lines, so I had the x value, and now I also have the z value. And the z value was negative 3 over 4. So I have now two of them. So as you can see, now you found x, you found z, and now you can go back to the original, and so take any of them. Now I'm going to actually take this one because it's the easiest one to work with. Okay, so I'm going to take this, I'm going to copy it. You can substitute it into any of those original planes, right? And now, so if you substitute this back in here, so what we're going to get, this is going to be 5 over 2 minus, this is negative 3 over 4. Sorry, we don't have the y value, we're trying to find it. We have the z value. So this is going to be negative 3 over 4 is equal to 2. So notice now you only have one equation, one unknown, very simple. So y is equal to 2 minus 5 over 2 and then plus 3 over 4. So whatever that is, so I can swing this back out. So the 2 negative, so 5 over 2 and plus, this is going to be 3 over 4 equals, all right, so that's a quarter. And I guess it's negative a quarter. All right, so there you go. So now you have found the point of intersection between those three planes. So that's the actual point of intersection, okay? So that's what you would have had. Now, let's do this, and I'm going to actually graph it out so that we can see this show up, so that we have those three planes, and then we can see that there's a point of intersection. I'm going to try to plot that point of intersection as well. Okay, so let me, take out. All right, so welcome back. Okay, so I have I'm plotting this on kind of the 3D plotter. So it's a CPM 3D plotter. Okay, so you can definitely do that. It's a 3D graph. Okay, there. And so those are my three planes. Now I know that I've kind of swapped this around, so this is kind of how it should look like. Okay, your Z is, okay, your Z is up. So you have the green, the red, and then there's the orange. I guess maybe let's change the orange. I don't know if I can make it. I don't know if that's any better. That's fine. I'll leave it at orange. Okay, so notice, and then I plotted the point. It's that blue dot there, okay, that you see within. Let me kind of go in here. Okay, so there you have it, right? So, so it is intersecting there, and that's the point of intersection in between. So I'm kind of spinning this around, but it's pretty nice and neat to be able to see that. And you can, of course, plot it out and then see, okay, how it looks like for yourself. So that's it. That's how you would go about trying to find that intersecting point. So these planes actually do intersect at one particular point. So that's another example for you, okay, that you have. Let's see, maybe, okay, I'll do, okay, one more example. Let's try this one, and we'll go through that same process. Copy. So we have one which is no solution. Now this one is a point, okay, and of course it could be anything. I mean, we don't exactly know what it will be ahead of time. So let's try this one. And technically, most of the times, the ones that you do get are going to be at a point, unless your teachers want to kind of test you. Remember, there's three things that can happen. They can intersect at a point, they can intersect at a line, or they can be intersecting at a plane. That means all three planes are on top of each other. So those are consistent kind of equations that you have, which provide you a solution. And then anything else really is going to have no solution. So they're not going to intersect. Okay, two of them might intersect, okay, at a line or something, but they may not intersect altogether. Okay, so let's try this one, and let's do this process again. So I hope that this one is going to be now a little bit easier for you. All right, so let's get to it. So I'm going to take these two planes and then see what happens. I'm going to I'll get rid of the y just by adding here. So notice, again, I'm just looking very quickly what's the easiest thing to do. So I'm going to be adding this up. So I guess I'll get rid of y again. So that is going to be, so the addition is 5x. Okay, the y is gone, and then this is 4z is equal to, and then the addition, so this is going to be negative 1. Great. So that's the first one. Now, again, you can choose any of them. I'm going to purposely actually choose these two because, again, so I notice the z's will cancel off, okay, within there. But notice because we have chosen the cancellation of y in the first one, we're kind of stuck. We got to get rid of y again. So that's fine. So if I want to get rid of y between these, these two, then I'm going to have to multiply this one by 5. So I'm going to get 5x plus 5y plus 5z is equal to 5. And then the second one, so this one's going to just stay alone. Minus z is equal to 0. All right, so let's subtract them. So I'm going to get 3x, and so the y is gone. And then we're going to get plus 6z is equal to 5. All right, so now I have my two. So it looks like it was intersecting at a line, and then this was intersecting at a line as well. Okay, so that means let's check now what happens. All right, so if this was the case, it doesn't look like they're multiples of each other, so looks like we're going to have an actual solution in here. So now we can get rid of, again, whatever it is that we like. Okay, so let's get rid of the x. Okay, for instance, now with this, so notice because you have a 5 and a 3, you can't just, I can't just multiply, let's say, the 3x, okay, by some nice integer. I would actually have to either multiply it by a decimal or a fraction to get it up to 5, and I could certainly do that. I can multiply it by 5 over 3. So that's something that I can do. Or, you can multiply both equations if you still want to just stick with integers. So for instance, between the 5 and the 3, so if you take these, so between the 5 and the 3, it's pretty easy, right, to find kind of the lowest common multiple within here. Okay, so it's going to be 15, so I can multiply this by 3, this one by 5. So that's what I have right there. And if you forgotten about that elimination, if you want to get more practice with it when the numbers are not very nice, I'll put up a link up above there for you as well. Okay, it will bring you back to grade 10 or so. Okay, so I'm going to multiply this by 3, multiply this by 5. So that's 15x plus 12z is equal to negative 3. And then my second one is 15x plus, it's going to be 30, z is equal to 25. So now subtract. So the x is gone. So 12 minus 30 is, I guess, negative 18. So this isn't very pretty, and that's fine. So negative 3 minus 25, so that's negative 28. So z is equal to 28 over 18. I guess I can reduce this. Okay, so I'll do that. Let me add a page there. So reducing this is going to be 14 over 9. So that's my z. So I found this one. Now I can go back. So now that I have this, I can now substitute it back into here. So it doesn't matter which equation. So whichever one you choose. So 3x plus 6 and 14 over 9 equals to 5. Now you have to solve for x. All right, so it does become annoying. Okay, so within here, actually 9 and 6, I'm going to reduce this. So divided by 3, so it's going to be 3, divided by 3, so that's going to be 2. So this is actually 2, and this is going to be 3. So 2 times 14, so that's 28 over 3 equals to 5. So bring this over. So this is stuff that you know, and you might have to refresh yourself on it, but you're just solving out. I'm getting a little bit lazy in here. Should be able to do that, okay, within, but I'll just cheat in here. So negative 3 over 3 divided by 3. So x is that. All right, so that's my x. That's my z. So far I have negative 13, 9. All I'm missing now is my y. This was 14 over 9. So that's going to be my point. And now I need to find a y value. And for my y value, well, you guessed it. You got to go back to the original. So you can... Okay, I'm going to clean this up. Okay, I can choose this one. It's the easiest one there. At least I don't want to deal with anything bigger than I already have with these fractions. Well, that's fine. So let me shift this. So let's substitute it in. So I'm going to substitute into that first equation. 13, 9 plus y plus 14 over 9 is equal to 1. Let's bring everything over on the other side. 1 plus 13 over 9 minus 14 over 9. And what's actually, this one's not that bad because it's already over 9 right there. So 13 minus 14, so that's going to be 1 minus 1 over 9, which is going to be equal to 8 over 9. So there you have it. So now you found your value. All right. So there it is. So this one also is intersecting at a point. All right. So that's what you would have in here. Now, you might be, you might run into the case where the planes are intersecting at a line, right? So if you want to find the equation of a line, right, and how to do that, okay, you can refresh yourself. I'll put up a link because that's something that, I did videos on, if the planes are intersecting at a line, okay? So you can go back and work with that if you wanted to. Then you would have to find the parametric equation of the line because it's in 3 dimensions. If it's a plane, right, then it's easy. That means the 3 planes would have their normal vectors just scalar multiples of each other. All right. So those are some examples for you. So 3 examples that force you to go through and find out what the answers actually are. So this is where we started off. So 3 equations, 3 unknowns. Basically what you're doing is you're just finding planes and you're working with them. All right. So thanks for watching. Okay. Happy studying. Maybe we'll see you in a future video. Bye, everybody.